So at this point, you may be wondering, how do we know when gradient descent has converged? Well, in this video, we're going to discuss that. So this is a type of curve you're going to come across a lot in machine learning, and it's called the learning curve. Okay, so on the y-axis, we're going to represent the cost function, or the error of our model. And you may be thinking, oh, what's going to be on the x-axis? The parameters, like w and b? Well, actually, no. What's represented on the x-axis is the number of iterations. So how many times we're looping through that gradient descent formula. So for example, a point here represents the cost function after 100 iterations. Another characteristic of our graph that we should note is that it reaches an asymptote. So you may or may have not learned this in your math course, but that's all right. An asymptote is when our graph approaches a value. So here you can see our graph is approaching 0 for our cost function. It's getting closer and closer to 0. And when this occurs in our learning curve, we can assume that gradient descent has likely converged. So in this case, by 400 iterations, in this specific scenario, it's safe to assume the gradient descent has converged, because the learning curve isn't really decreasing anymore to a great extent. You can see that here, the learning curve was decreasing quite significantly, but over here now, it's not really, because the cost function is almost at 0 already, so there's not much room for it to decrease anymore. And you can see that the learning curve is always decreasing. If you have a learning curve that looks something like this, where it spikes back up, there's something wrong in your model. If j ever increases after one iteration, that means either alpha is chosen poorly. So remember we talked about how if our cost function is represented by something like this, and if alpha is too big, it might actually jump around and never reach the global minimum. Well, when it goes the opposite way, then the cost function is actually increasing. So that's why you might get something like this, and that'll indicate to you that alpha is too large, it was chosen poorly. There might also be a bug in your code. And the number of iterations does vary. So, in some cases, you may reach an asymptote at around, maybe 100 iterations. In other cases, it might take something like 1,000 iterations. So it really varies case by case. And the way to define convergence is we'll actually let a variable called epsilon be a significantly small number. So let's say 10 to the power of -3, which is also 0.001. And if the cost function ever decreases by less than or equal to this number epsilon, we can declare convergence. And this is safe to assume because when our cost function is decreasing by such a small value, this means that there are no more significant changes in the cost function, and we've likely reached the asymptote of our learning curve. So you can see here, our learning curve in this area isn't really decreasing significantly. And in this case right here, right, when it gets really flat, it's barely decreasing at all. So you can say the cost function is decreasing by less than 10 to the power of -3, which we denoted as this variable over here, epsilon. And then it's safe to assume that gradient descent has reached convergence and our cost function has thus reached its minimum, meaning our model will hopefully work. Thank you.